Now let's discuss how to do all these calculations and plots in R. We will use the same people data from the last exercise. So I just copied and pasted these 5 lines where I load this package, read Excel, that can read data directly from Excel file. Then I read data from people XLSX, and I will use the variable DA, means data all. Later I will also create subsets for males and females. And then I do this little trick to get the names correctly. By default, when I use read Excel, the names for the rows are allocated as the values for the first column of data frame. So I get the names, I remove the first column, and then I use the names, I use the variable names to define the row names. Okay, so you can just copy and paste these lines from your previous exercise, but remember that the variable name is different. Okay. Well, first thing I want to do is to create 2 subsets, DF and DM, where there will be data only for males and females. So I just say use function subset. The first argument is DA, and then I say sex equal to, this is female, so it should be 1. And then for males, I do the same, but the variable sex should be equal to -1. Okay, so I'll just run this. Oh, I need to run the first 5 lines as well. Okay, so if you look at my global environment, you can see that I have 3 data sets, DA, DF, and DM. In DA I have 32 observations, it's all data, and then I have 16 in F and 16 in M. Okay. Then the next thing, I would like to define which variable I want to work with. The idea is that we will write a script, a universal script that you can reuse for any variable. So I'll just say var name equal to, let's start with height. Okay. So now we need to get height values, all values, and then separately for males and females. Now I need to get the values, so I will use VA for all values. And then in this case I will do the following. I use DA, and then I will subset it like this, var name. Okay. Look, this is the variable, it's not the real name, but I define this variable to be equal to height. Okay, so it means that if I run this code, it will take the variable, the column height, and got the all values from this column to VA. Okay, why this way? Because now I can change height, for example, to weight, and the script automatically will change the values. Okay, so it will get the values from the weight instead of height. So that's a very convenient way if you want to analyze, if you want to use your code to analyze several different variables. Okay, so I will do the same for VM and VF. You see the code is very similar. I'll just use another subset. So DM, we have DM for the male values, and then I take the column height from the DM and assign it to variable VM. And then VF, it's DF, and also var name. Okay, so if I run these lines now, look, I have VF, it's a vector, 16 values, it's a height for females. We have VM, also vector with 16 values, and then I have VA, it's a vector with 32 values. So now I'm ready to start doing something. So first of all, let's learn how to calculate statistics. Calculate statistics. Okay. There are many different functions that you can use to calculate statistics. I will show you just some of them. For example, show mean VA. Okay. So it will calculate, the function mean calculates the minimum, the smallest value for VA, and then it will show it on the screen like this. So we know that the smallest value is 157. Okay. Then you can, for example, calculate several mean values and combine them together like this. Mean VA, mean VM, and then mean VF. Okay. So this will calculate the minimum, the smallest value for all data. This will calculate the smallest value for males, and this will calculate the smallest value for females. Then I combine the 3 values together using function C. Okay, and then I can show the combined values like this. So look, so we have 157, it's a minimum for all data, 175 for males, and 157 for females. Okay, we can also add some names to see what is what, all, then males, then females, And then we can see that 157 it's all data. Then for males we have 175 and females we have 157. Okay. Similarly, you can calculate, for example, the maximum. I will use only VA in this case. So you can see that that's the maximum height for all data. And you can calculate range VA. Range, it's a minimum and maximum value. So you can see that that's the minimum value and that's the maximum value in all your data. Okay. What else you can do? You can calculate quantiles, percentiles, quartiles. There is a function which is called quantile. And this function has two arguments. First of all, you specify the vector with your values, with your data values. Then you specify which it's sort of percentile, but in the portion of 1. For example, if you want to calculate the 5th percentile, it will be 0.05. Okay, so in this case, it calculates the 5th percentile, 159.1. Okay. Then similarly, you can calculate, for example, the first quartile. The function is the same. Remember that quartile is a value that it's a border between 25% of the smallest and 75% of the largest. So this percentile or probability, it's called, will be 0.25. So that's our 25th percentile. And you can see that function quantile also adds names, so you can see which quantile is it. So I recommend you to play a little. You can also specify these quantiles, the probabilities, as a vector. So if I do it like this, quantile VA, and then I use a vector 0.25, 0.5, and then 0.75. So I say calculate not just one quantile, but 3 with these probabilities, 25%, 50%, and 75%, and I will get the vector with 3 values. So these are quartiles, the first, the second, and the third quartile. So this is the median. Okay. There is also a very useful function that is called summary. And this function can be used both with a vector or with a whole data frame. I'll show you the difference. Summary calculates the main statistics. It's a mean, the first quartile, the median, the average value, the third quartile, and the max. So it's actually all you need to make a box plot, for example. And the point is that you can also apply this function to the whole data frame. For example, let me use data frame for all values. In this case, it will calculate these statistics for every column and return it as also its sort of table or data frame. Let me show you how it works. So because I have a lot of variables, the screen size is too small for them, and it splits all the table into several rows. So you can see that, for example, that's the height, that's the smallest value, the first quartile, the median, the average, the third quartile, and the max. And then you have the same values for every column in your data set. It's very convenient if you have more than just one variable and would like to have a quick statistics for the all values. Okay. The next is how to make a dot plot. Well, you remember the dot plot, it's a plot where you have the x values, but you sort of don't have y values. But of course you can't make a plot where you don't have y values. So the point is you generate y values, for example, the same, like equal to 0. Let me show you how to do that. So we use plot, then we have x, and instead of y, I use the following. I will explain. Of course, it's not x, it should be, for example, let's take the all values VA. Okay, length VA. And then I say type equal to p. I will run it first and then explain what I have written instead of the y values. Okay, so look, that's exactly what we need. We have the x values here. It's a height of all people. We have 32 points. And then we have, this is the y values, okay? And you can see all of them are equal to 0 for the points. The function rep, it repeats anything as many times as you want. I will use a console to show some examples, okay? So for example, if I say rep 0, 3, it means repeat 0 3 times. So I will get a vector with 3 zeros, okay? If I say rep 5, 5, it will repeat 5 times. So I will get a vector with 5 values. You can also repeat a letter, for example, repeat A 5 times, so you'll get a vector with A. Okay, very useful function. Okay. So in this case, I repeat 0. How many times? That's another function which is very useful to know. It's called length. length returns number of values in a vector, in a whole data frame, in anything. So length VA, again I will use console to show you that, length VA will return 32 because that's exactly how many values we have. Length VF will return 16 because we have only 16 values. So it means that when I run this code, this part of this code will repeat 32 times. So for every value in VA, I will have 0 for the Y. Okay, so that's the dot plot. But of course, this dot plot doesn't look very good because we have this sort of Y values, Y axis, which we don't need to. Okay, you can remove any axis by just using a special argument in the plot. For this particular case, it's called YAXT. Then you just say it's N, so it means no. So you don't have any Y-axis anymore. Okay, and you can understand that if you write XAXT, it's equal to N, it means no X. Okay, the last thing we need to get rid of is this one. It's Y label, and we just set it to empty. Ylab equal to, and then empty string, so it means nothing, and so we get rid of it. Okay. Now we can also add some, for example, lines like I did it in my examples. Let's show the mean, the max, and the median values. Okay. So we know that there is a function AB line that can add horizontal or vertical lines. In this case, we need a vertical line, and then I just say mean VA, and say the type equal to 2, it will be dashed, and then I will make it, for example, red. The color will be red. Okay. So now you see that we have a line that shows where the minimum value is. Okay. Now I can do the same for the maximum value. I just copy and paste and change function min to max, so it will show me where the maximum value is. Okay. So that's the maximum value. Then I also do it for the median. I can use function quantile to calculate median, but actually there is a function that calculates median. It's called median, so it's very simple. Now I also see a median, so that's the median. You can count that you have 16 values here and 16 values here, so the position of the median is correct. Then you can, of course, play with it, add a grid, and, for example, change colors, but that's what you already know what to do. One small thing, you see that we have VA here, okay, because the X variable is VA. And you remember we defined a name for our variables, which is height. So we can just use this name here. I will add xlab equal to var name. So if I create the plot now, I will see height here. Okay, and that's a cool thing because now I can change the var name and everything will work for the new variable. So I will calculate statistics, for example, for weight, and show the plot for weight and so on. So you don't have to rewrite your code if you want to change the column, if you want to change the variable. Okay. Now the next thing is a box plot, how to create a box plot. And there is a function that's called box plot. And the arguments, it's a vector or it's two vectors. I will show you later the difference. Let's start with a vector, for example, VA. So that's the box plot for one particular variable. And you can see that you have values here, and then you have some groups here if you have several box plots. Okay. You can also change the Y label, this var name, so you can see height. Again, if you change the var name, the box plot will show the correct name here. Okay. I can also write box plot, and then, for example, VF and VM. Now I have two box plots, one for the first vector and one for the second vector. You see it identified one of the value as an outlier. If you get back to the dot plot, you can see this value here. So if you have all values, it doesn't look outlying because you have a big spread. But if you take only males, for only males, it's most of the values are here. This looks like an outlier, so therefore it shows it as an outlier here. Okay. Then you can also check the minimum and the maximum and the quartile, so all calculated correctly. As you see, when you create a box plot for several vectors, it uses numbers to show the groups. Actually, you can change this and write real names. In our case, we know that these are females and these are males. You can specify these names using the argument, which is called names. And then because we have two vectors, I need to specify two names, say females and males. So if I run this code, you will see the real names here. Okay. And because this is just a plot, you can do everything you want to, you can usually do for the plots. For example, you can change the color, and you'll see the blue color. You can also change the color for the borders. So you can just look at the help if you want to find a little bit more about box plots. Okay. Another very useful thing is for the box plot is to use box plot for the whole data frames. You remember we made scatter plot for the data frames using a special formula, like a relation between two variables. You can also do it here, but in this case one of the variables should be discrete or qualitative variable. Let me show you an example. So we'll make a box plot for all data. So I will use DA here because it's a data frame. But I need to specify the formula first. So I say, for example, the height. In this case, I have to write height and relate it to, for example, sex. So it means that the variable sex will be used as a grouped variable, as a variable to create groups. We have only two discrete values, -1 and +1 here. So height will be split into two vectors, and then you will show the box plot for these two vectors. Data equal to DA. Okay, so that's it. So we have males and then we have females. You can also change it and, for example, write region. Okay. Now you can see it for region. So we have, this is the Scandinavian region and Mediterranean region. You see that there is no big difference for the region. Actually, you can combine several grouping variables like region and sex by using function plus. So it means that it will take all possible combinations for region and sex and create a separate vector for each combination. So we will see males from Mediterranean, males from females from Mediterranean region, and then the same for Scandinavia. So I'll just do it like this. So you can see that this is where both variables are -1 and -1. Then the first variable, in this case it's region, is +1 and -1 and so on. You see very strange structure here. It's because we don't have enough data to calculate all statistics. So in this case we have an outlier, we have minimum, maximum value, we have 3 quartiles, and we have only 8 values here. So the number of values is not enough to calculate the statistics correctly. Then of course you can also change the label names. So in this case you can specify, for example, the names like the first is males from Scandinavia, then you have males from Mediterranean region, then you have females from Scandinavia, then you have females from Mediterranean region. If I run it, you can see the correct names for the groups. Okay. Then the distribution histogram, there is a function hist, and you just specified again the vector. Let's use all values VA, for example. So that's the distribution histogram for height. You can also change the color. Let me use a blue color, just for making it contrast. So that's the distribution. You can see that the distribution is called its bimodal. So it has 2 peaks. You can imagine that one is for females, one is for males. So we have actually 2 distributions here together. And then you can see also the outlier, the male person whose height is much larger than the others. Okay. The number of beans is identified automatically. You can suggest a different number of beans, for example, by using this breaks equal to, for example, 5. Okay. So, but I was lucky enough to get 5, but usually R finds the optimal number around this. So it's just a suggestion. It's not a comment. For example, if I change it to, I know, to 3, I will still have 5 because R assumes that 3 is too small in this case, and it uses the 5 values. So once again, you can only suggest the number of the breaks. If you want the particular breaks, you can specify them. For example, instead of the number, you can specify like, let me say 150, 160, 170, 180, 190, and 200. Okay, so these are the breaks. And in this case, R will use exactly the breaks you specified. For example, you can see the first bean is between 150 and 160, then we have 160, 170, and so on. Okay, and then we have exactly 5 beans because we have, in this case, we have 6 numbers because we need 6 numbers to specify 5 intervals. What else you can do? By default, you see that the R shows your relative frequency here, or the real frequency, not the relative one. You can specify, you can make this plot for the densities, for example, hist VA, and then you specify a parameter which is called frec. Frec, it's a frequency. It's a logical parameter. It can be true and false. True, it means use frequencies. False means use density. So if I use false, you can see that now it's density. The shape, again, the shape of a histogram is the same, but in this case it uses density for the height of the bars. The density is good to use if you want to show also some theoretical distributions, which we are going to discuss in the next lecture. Then you can calculate a curve for theoretical distribution and show the real distribution and the curve for theoretical distribution at the same plot. And one more important thing is that hist is just a plot. Hist also calculates a lot of things, these densities, frequencies, and so on, and you can get them. In this case, you just write some variable, assignment, and then function hist va. If you don't want to make a plot, you just say plot equal to false. So it means calculate everything, then just don't show the plot. Okay. So now you see we have a function res, which is list of 6. List, it's like a data frame, but in this case you can combine vectors of different length. So if you open it using this triangle, you can see what is these 6 values are. It's breaks, it's your splits, it counts, it's the frequencies, so it's a frequency table. It's densities for every bean, it calculates densities. Meets are middle points, the middle points for the intervals, and then it has some other things like x name and so on, which are not very useful. Okay, I can actually use these calculated things to make a plot, like a curve. I can write plot, then I say res dollar meets, that will be my x values. Then I can say res dollar, for example, counts, it will be my y values, and then I will specify type equal to, for example, b. So you can see that this is like a distribution curve or a distribution polygon. Instead of the bars, I have points and the line segments connected to points.